Hello dear viewers. These samples of fulgurites are made in the laboratory, and they look like natural ones. In nature, fulgurites are obtained from lightning strikes on sand, earth, stone, etc. The energy of the electric discharge melts any minerals into a glassy porous substance. The result of laboratory technology in various variations can be viewed at the links in the description. These samples were obtained on the basis of local quartz sand, to which various elements were added. Such a wide list of additives of the elements that are indicated in the title has various goals. Synthesis technology gives a certain selection of minerals at the output. It is believed that the synthesis of ruby in the usual way does not accept impurities that can eliminate the effect of fluorescence in UV. But this technology makes it possible to obtain well-fluorescent ruby fulgurite from dirty reagents, which is presented at the links in the description. In these samples, it is almost gone and the UV test is not shown. It is possible to obtain other minerals using the necessary reagents. So far, quartz sand and a little aluminum oxide have been used, because funding for the work is not yet available. If funding is available, it will be possible to purchase the necessary reagents and make samples of ruby fulgurite stone better than those presented on the links, as well as other minerals. The cost of laboratory synthesis of ruby fulgurite was about $2 per 1 kilogram. Sandy fulgurite is about 50 cents. With serious funding, it is possible to increase the power of the reactor and synthesize larger stones. With sufficient power, it is possible to create large blocks for structural purposes and decorative applications. Work out the technique and get repeatable textures and strength. Additives of thorium and potassium were made to evaluate the application of technology for binding liquid radioactive waste to sand. Measurements of the activity of such samples are repeatedly given by reference in the description. It was also noticed that when potassium was bound to sand, the resulting stones had an increased activity compared to the original potassium. This observation may indicate the passage of low-energy nuclear reactions in the process. If you have studied various studies on this topic, then you should have the assumption that during the synthesis of fulgurites by an electric discharge, similar reactions may well occur. It is easy to find out if there is funding for the work. The synthesis of various minerals with a fulgurite structure is also possible. Syntheses of an alloy of iron oxide powder with glass were carried out. They can be found at the links. They have soft magnetic properties. There are plans to carry out syntheses of other compounds from the available reagents. The synthesis speed allows materials to be melted in a few minutes in a small volume, which can be studied immediately, rather than waiting for a long warm-up of a conventional furnace. The synthesis temperature can be any. Only electric arc furnaces have similar parameters. There is great interest in increasing the power and voltage of fusion, the higher the voltage. The higher the energy of the electrons and the more likely the synthesis of new materials with unique properties. The rafting of fertile soil was carried out for evaluation. The resulting samples are presented in the links. They are quite durable because, based on aluminum oxide, such a material is of scientific interest in terms of studying the connection of inorganic and organic materials under electric arc conditions. It is planned to fuse various organic materials for study. There is evidence of finding masses of complex hydrocarbons after a lightning strike into a haystack. It is quite possible to use this technology for waste processing into hydrocarbon concentrates, which can be analogues of oil. Hardness is clearly shown in many videos on the links in the description. Through glass scratching, ruby scratches noticeably easier than quartz, which corresponds to the known properties. If you imagine a future with great electrical possibilities, for example, electricity received from a volcano in gigantic volumes, then you can draw incredible pictures. Huge blocks with walkable cavities can be used for construction, and the fulgurite texture adds a futuristic organic feel, covering deserts with glassy crusts, which levels the dust storm. Construction of durable underground cavities. While it is difficult to really assess the possibilities, you can offer your idea in the comments and perhaps someday in the future it will be implemented. Thank you for your attention. Send your funding for further developments, and maybe even reaching a new level of work. Smiley face.